Okay, so we'll talk a little bit about the makeup of atoms. We're going to talk a little bit about the makeup of the atoms, and we're also going to talk a little bit about how we got our first atoms, okay? Now let me go into full screen here, make it a little easier. Okay, so you remember we said that atoms are the building blocks of the universe, right? Everything in the universe is made up of some kind of atom, and that 99% of the human body is made up of just 6 elements, right? 6 elements. And we said that elements are pure substances made up of one type of atom. We said that. Richard, are you with me?
Yeah.
I need you to pay attention here.
Way off.
And then we said that atoms, sometimes you can put different atoms together to get pure substances like water, salt, and chalk.
That's all I found for the 14.
Okay. And then we did some questions. Okay, so now we're going to talk a little bit about what atoms are made up of. Okay, this is kind of important here now. So atoms are made up of 3 parts. Okay, and we're going to talk more about that later, but this is just to give you a general idea.
Okay.
Atoms are made up of 3 parts known as subatomic particles, and each part has a different charge. Okay, the protons has a positive charge. The neutrons have a neutral charge, and the electrons have a negative charge. So I always think P positive. Matter of fact, if you look at Mr. Hughes's mask here, it says, what does it say? Stay positive, think like a proton. Think positive, stay positive, think like a proton. Have you seen that on my mask?
Yes.
Okay, so protons are positive, and that's how Mr. Hughes is thinking right now. I think Mr. Hughes is thinking positive. Neutrons are neutral charges, and electrons are negative charges, and we'll talk more about them here. Okay, so how did we get the first atoms? Well, let's find out. Okay, so have you guys heard of the Big Bang Theory?
Yes.
Okay, so you've heard of the Big Bang Theory. Well, so when the Big Bang first happened, the universe was very hot. Okay? The universe was very hot. And this is a word here, or a number that I can't even fathom. I can't even imagine how big this number is. But look at all those zeros in it. Woo! And so it was, and the number is 20 octillion. Okay? So the number is 20 octillion. It's 20 octillion times hotter than our sun. And our sun's pretty hot, right? Okay? Okay, so, and after a few minutes, literally after a few minutes, it cooled down to the point that protons and neutrons were able to join together. Okay? Protons are positive and the neutrons were neutral, right? Now, at this point, there wasn't an electron. There were no electrons, and I'll show you something here.
There's no electron?
Okay, so soon after the Big Bang, these particles, the protons and the neutrons, captured object called electrons. And when this happened, the first 2 elements were formed, okay, and the atom. Okay, so anybody have any idea of what the first 2 elements were? Look right here. Uh-oh. Oh, we gotta move the box, I'm sorry. Look right here, here's the first two elements. First 2 elements, hydrogen and helium. Okay, so let's talk about those, hydrogen and helium. Let's talk about those elements. Okay, so first off, let's look. You're going to need this information right here. You need to know this right here. Opposites attract. look here, here's a proton that is positive, and here's an electron that is negative. I wanna show you an illustration. Let's pretend this is a proton. Well, let's do the red. Let's pretend this is a proton. Let's pretend this is a proton, right? Pretend this is a proton. Red. And the blue is gonna be an electron. Red and blue, they attract. They're opposite, right? Opposite colors. Look here, red, blue. They attract, don't they? Right? Like
Yes.
it's a magnet. It's like a magnet. Same way atoms are. Atoms are similar to a magnet. You got the electrons trying to get to the protons. How about if we put blue to blue? How about
It won't.
two electrons? Do they go together? No, they actually repel each other, don't they?
Yes.
You can see that. Yeah, see, they won't even stick. But this proton and an electron opposite attract. Okay. Okay. So it's that simple. It's that simple to understand. Okay, so opposites attract, the proton and electrons attract to each other. So what does this mean? What this means is that just like a magnet, the positive protons and the negative electrons attract each other. Look right here. So how are atoms arranged? Well, we know that an atom is made up of protons, neutrons, and electrons. That's what I just said, right? And so, but how are these three particles arranged in the atom? Look right here. Here is the center of an atom, it's called the nucleus. Look right here. Here's the center of the atom. It's called the nucleus. And protons and neutrons are found here. So here's the green is the proton, the blue is the neutron, and right here, electrons, the reds, they move around the nucleus in the electron shells. Okay, so they're on the outside of the nucleus. Proton, neutrons inside the center of the atom, and that's the nucleus. Electrons are on the outside trying to get to the protons. Okay, because why? Opposites attract, right? Okay. And you see the space, all the space in between here?
Yes.
That's all empty space. All empty space. It just can't, these electrons are trying to get to the protons. So the space between the nucleus and electron shell is empty. Okay, so there's a relative size of atomic particles. So essentially you could imagine that an atom filled the distance from New York City to Ohio, which is about 1,030 kilometers, and that'd be about close to 700 miles. And then in that scale, the nucleus would be about the length of a football field, and then a football field is only 100 meters. So a proton would be about the height of a 3-story apartment building, and that's about 9 meters, which is about 9 meters would be about 30 feet or so. So an electron would be about the width of a blueberry, and a blueberry is only 1 centimeter. Woo! So in other words, it's very, 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 very small. Gentlemen, are you with me?
Yes, it tries his Chromebook. Yes, it tries his Chromebook.
Well, help him out there, would you? Okay. Okay, so let's look at the first two elements here. Let's look at the first two elements. Okay. Okay, so again, we're having some computer problems here, and that happens sometimes when you're giving a lesson. Let's get your Chromebook plugged in. Just have a seat there. There you go. Here, let's turn your desk around so Let's go back to the lesson now. Are we all good now? Okay, that happens sometimes, that's okay, it's not the end of the world. Okay, I do want you, there's something very important I want you to see here. Look here, I want you to see this. You remember we said hydrogen and helium were the first two atoms that were created with the Big Bang, right? Okay, well hydrogen was actually the very first one. And look what hydrogen has. It has one proton. Hydrogen has one proton and one electron. Where's the neutron? What? Where's the neutron? There is no neutron. What happened to it? Well, hydrogen just does not have a, hydrogen, which was the very first element, and our sun is made out of hydrogen and helium. Hydrogen also happens to be the most, it's the most widely known element in the universe is hydrogen. Most abundant. There's more hydrogen than there is anything else in the universe. So scientists say, right? Okay? So hydrogen has one proton and one electron. And then helium was actually cloned out of hydrogen. And look what helium has. Helium has two protons and then two neutrons. And how many electrons? How many electrons? Aaliyah, how many electrons?
Two.
2 electrons, good. 2 electrons, 2 protons, and 2 neutrons. Okay? First 2 elements in the universe.
Oh.
I'm sorry, what's your question?
Never mind.
You have a question? Okay. Okay. Now is your time to let's get some answers here. Let's do a little reading check, see what we've learned here. I know you've learned something. Okay, so which subatomic particle has a neutral charge? Is it the proton or the neutron? Which one has the neutral charge? Mark your answer.
I did.
We'll talk about it shortly, just mark your answer.
I did.
Mark your answer, good. Everybody got an answer?
Yes.
You can either type, put a box,
Can I-
put a box around a circle. I like the way you guys put the circles around it, that's kinda cool. Or you can put a box around it, or you can highlight it, or you can mark it, your choice, underline it. Okay, so which subatomic has a neutral charge? We said proton or neutron, you can't choose electron. Now we'll move to the next question. So which of the following subatomic particles are found in the nucleus of an atom? Which one are found in the nucleus of an atom? Is it the proton, the neutron, or both A and B? You can't choose C. So proton, neutron, or both A and B? They're found in the nucleus. Now look, don't guess. Go back here to this picture right here and tell me what's in the nucleus of an atom. Go back to that picture before you answer this question. Which of the following subatomic particles are found in the nucleus of an atom? Go look at that picture and then come back here and give me an answer. You can't choose C. You can choose A, B, or D. Look at the picture and see what's there, and then come back and answer this question. Okay, everybody got an answer? Okay. Is it? You got an answer, Richard? Richard, you have an answer? Answer, Tyler? You got an answer? You got an answer, Lexi? You got an answer, Aaliyah? Okay, I'm gonna give you a couple of seconds here.
We got, everything got two.
Okay, I'm gonna move on here now. Okay, so, oh my, okay, so you're gonna label these, look right here. I say label, you're actually gonna choose A, B, you're gonna choose, you are going to choose A or D. Okay, you're gonna choose A or D, you can't choose B or C. Number 1, is number 1 protons or is number 1 electrons? There's your hint. Okay, is number 1 protons or is number one electrons?
Today.
Mark your answer.
I did. Did you? You did not. No.
A or D, can't choose B or C. Look at these right here, 1 is something, 2 is something, and 3 is something. Okay? Got an answer? Okay.
This is my shield for
Do we have an answer? Need another computer? Let's try another computer here. Was Miss Webb able to look at it, or?
Yes, she was sitting there about over 30 minutes.
Oh,
Looking
okay,
at it,
that's fine.
and it's not working.
Okay, let's get, let's get finished with this, next question here. Everybody got an answer to this question here? It's A or D, that was your choice. And that's where we're gonna stop. We'll talk about how we measure matter tomorrow. We'll talk just a little bit about that. We're not gonna talk a whole lot about that.